Hey, what's happening guys? In this video, Peter walks us through creating a rate limited function in Clojure. It kind of follows on my previous video, which is in the description below, but you don't have to have watched that to watch this one. So let's get into it. Uncool, yeah.
Right, so we have an example of this wrap once function. What if we wanted to have it based on a period of time? So it can only be called once every 100 milliseconds, or it can only be called once every 3 seconds, or something like that.
Once in a while, you can call this function.
Once in a while, okay. Wrap, I like that. Once in a while. All right, and we know that the basic structure is going to be the same, right? So we're taking an f, we're returning, let's just call it wrapper, and it's going to be args.
And just one thing with that anonymous function, you don't actually have to pass it a name.
Yes, that's a good point. The common convention is to go without a name. I'm choosing to add a name in this case, just, well, two things. Number one is a form of documentation to the reader of the code. We're just emphasizing the fact that this is a wrapper. The other thing is if there's an exception of some kind which happens to be thrown within the wrapper, I believe that you'll actually get a clear error message in this case. So imagine the wrapper is going to throw an error of some kind. Let me check to confirm that what I'm saying is true. So wrap once in a while and say hi. So this is returning the wrapper function, and now I'm going to call the wrapper function, and I will call it with the word hello. But what I'm expecting is it's actually going to throw an exception. And what I want to check is it may include the function name. Let me confirm that this is actually happening the way that I'm expecting. Yes, it provided some extra documentation over here as well in the stack trace. And what I would say is this is can be a useful convention sometimes if you're dealing with a lot of anonymous functions, because what tends to happen in production, if you're using a lot of anonymous functions, which idiomatic Clojure often uses a lot of, it may happen that when you have issues in your anonymous functions, you get error messages. Well, I can show you an example here. You get error messages which are a little bit difficult to parse. You get something like this. Where you'll see that some sort of a function has failed. And anyway, just providing some breadcrumbs a little bit for what function are we actually talking about, I find can be helpful. We're starting again over here with the degenerate case, which is we're just going to return a wrapper that just calls straight through to the function. Okay, and again, REPL development, so we can just quickly actually check that this is doing what we expect. So I'll call the wrapper function, wrap once in a while, say hi. And we'll call it wrapper function. Let's just call it 1, wrapper function 2, wrapper function 3. What we're expecting over here is that we're getting back hello 1, hello 2, hello 3, and it's printing all 3. Right? So it's just a sort of identity wrapper at the moment, I guess you could call it. And what I'm doing over here, I'm pulling up the previous implementation on the side so we can remind ourselves, all right, what's the general format of what we're doing over here? So we have some sort of a state. And the idea is going to be, now we want to change the behavior logically so that instead of just checking whether we've run once or not, we're checking whether we've run once in some prescribed window period.
So now we need to keep track of the last executed time versus whether it's run or not.
So maybe we have something like last executed over here, atom. And since it hasn't been executed in the beginning, maybe we use nil, something like that. And we're going to apply, implement some sort of a logic over here. How would you describe the logic? What is it that we're actually trying to do?
So we need to check if the time now is a certain period of time from the last run. Then if it is, we'll execute. If not, I don't know what we'll do.
So let's say if current time is bigger or equal to x milliseconds since last execution, return f, something like that.
Yeah.
Else return nil. So how do we get the current time? One way to do that is system current time millis. And if you call that in Clojure, you just get the current milliseconds system time. So how do we actually use this? What are we planning to do? Well, there's an interesting point over here. When we write out the intended behavior, it's clear that there is a configurable thing over here, right? So we said greater or equal to x milliseconds since the last execution. What is x? This is, again, a nice example of where a Clojure with an S can be useful, because we want this thing to be configurable at the wrapper level. We want this to be, let's say, sex period, something like that, which means all of the consumers of this new version need to provide a value for x. So we'll say period. They need to provide a value for this period. So wrap once in a while, we're going to say 100 milliseconds, and then the function body. By the way, this is a deliberate choice on my part to put the configuration argument before the function. And the reason for that is it's more convenient to do partials. So if you do a partial of wrap once in a while. It would be more common to want to do a partial for the configuration parameter than for the function. And also because if you want to write a inline function, right, x, y, something like this, times x, y, whatever, so something like this, I generally prefer to have the longer multi-line argument as the final argument, because then at the when you're writing your code, you can write it something like this. If you can pair that to something like this, for example, I find this a little bit of a pain, especially if this ends up becoming a multi-line thing, because then you've got this big multi-line chunk of code and then a little dangling argument at the end, which I find a little bit more difficult to read. If we start adding more and more configuration options, instead of just piling on more and more arguments to the front of this thing, the idiomatic solution in Clojure, for lots of good reasons, would be to actually switch this to something like an options map, so that when you call wrap once in a while, this is actually going to be something like period 100, and then maybe there's some other options or whatever over here, and then you can have your function body. So now we're taking this argument, milliseconds period, and we've written already over here what is the logic that we actually want to use. What is the syntax going to look like to implement this kind of thing?
Well, I suppose the first thing we need to do is like do another when, and we'll get the current system time millis. I don't know if we want to do a when let or something like that. And then we'll have current time t now. Yeah, get system's current time. And we can actually have difference like there at the top as well, if we wanted to just make it a bit clearer inside of the let. So we could have
difference? Mm-hmm.
So it would be t now minus last executed. But now we have an issue if last executed hasn't been set.
One convention which I tend to use, if I want to emphasize the fact that the value that I'm dealing with might be nil, and that I want to handle the nil and non-nil case differently, a convention that I often use is to prefix the simple name with a question mark to say that it may be a nil thing. Then what we can do is something like this. If let last executed, and we'll do last executed, except you'll see this should not actually be an underscore. Then we have behavior if we have a last executed timestamp, and behavior if we do not, something like that. Does that make sense? In other words, at this point in the code, we have last executed value, and it's non-nil. And at this point in the code, we do not have a last executed value, and we know that the version with the question mark is nil. What behavior do we want over here? So we have now, and we have non-nil last executed. And as you were suggesting before, it might be nice to have like the delta. So now minus last executed. And then what behavior are we looking for over here?
So inside of here, we need to check if the delta is less than our m6 period. Then we want to execute our function. Then we'd also actually, we can do this outside of this branch because we always need to do this, is update the last executed to be now.
Hold on, you said we always want to do this.
Yeah, actually we don't, because it won't, only when it's running do we want to actually update
last
executed.
But that's an interesting question, right? Do we want this over here to be updated when the wrapper is called or when the wrapper body is successfully executed?
Yeah, I would assume when the wrapper body is successfully executed.
Yeah. It's an important distinction to make. It's the reason that we've actually used this terminology executed over here. So it's not about when there was a last attempt, but rather when there was a last successful attempt, which means that it's in this branch over here that we'll actually want to return this thing. There's an interesting question, which is where do we want to place the ordering of this? Because here's the call to F. That's multi-arity. We're going to run into a problem here in a moment anyway, but let's just keep it simple for now. Executed now. Do we want to do it this way, or excuse me, this way, or does it matter? How do we want to do the ordering for the state update? Does it matter?
It would matter if the function could throw an exception, I think.
That's an interesting case I hadn't even thought of. If the function throws, do we want to count that as a completion for the purposes of the rate limiting?
I would say that after the function is called, then we say last executed, so that we know it's a successful execution. Otherwise, we'll return null and we just try it again.
This is one of those examples of where when you're actually implementing something, there sometimes ends up being a bunch of tiny little, very detail-oriented things. that you need to make some decisions about. And you need to think, well, actually, what is the behavior that I would want? And maybe it's a little edge case or something like this. And these can be very interesting situations to consider because they influence ultimately what kind of API your consumer is going to get. What's ultimately going to need to go into your docstring, right? One of the really nice things about Clojure's docstrings, in my opinion, they tend to be very terse, but they tend to be very specific about what they're making promises about and what they aren't. If you look at a Clojure core docstring and it doesn't mention anything about some specific detail, that implies that that detail is not under API contract, right? You shouldn't make any assumptions about what's going to happen with respect to that detail. One of the things that we need to think about when we're writing something and we're writing our own docstring is what is it that we actually want to promise as part of the API? Because anything that we leave unspecified, we're effectively communicating to the consumer, hey, don't make any assumptions about this thing unless we specifically made a claim about it. If you notice that you're making some sort of a strange decision in your implementation that might affect external consumers, then the implication is, well, maybe that thing should be documented. But if you're going to document it, that means now you're making it a part of the official API. Then you have to ask yourself, well, do I want to make this like a guarantee that that's always how the API is going to work? Clojure, thankfully, tends to be very averse to making unnecessary breaking changes. I would like to encourage Clojure developers usually to try and maintain that way of writing our own code. So we're checking on this branch, do we have a last executed thing? So this whole form over here is our branch for something was previously executed. So I'll just mark this over here, have previously executed, F. Delta is how long it's been since we last executed. If the delta is smaller than the msex period, we're going to get the result of rerunning F. We're going to update the state, and we're going to return the result. There's a couple issues, but we'll come to them sort of in order, the direction of this inequality. So what we're saying over here, the delta is basically the elapsed time. Maybe I changed this actually, elapsed. All right, so this is how much time has elapsed between the last execution and now. And the actual functionality that we want, or the behavior that we want, is we want to check has more than the minimum amount of time elapsed. So basically what I'm advocating for is that this
can only run within a certain period of time. Yeah.
Exactly. Yeah. So what we're looking for over here is this this branch over here. If the elapsed time is at least, maybe even do it like this. But here's again a little example of what's the API. Is it greater than or equal to? And in fact, that's the kind of thing I would suggest should be clear in the docstring. So we just put a little reminder over here. Bigger or equal to. And we need to think about that. In this particular case, I think it's probably reasonable to just presume that we're going to do bigger or equal to, but we will make a note then of making that clear in the docstring. So if enough time has elapsed, we're going to calculate the result of F, then we're going to reset the state, then we're going to return the result. And we notice in the ordering of this argument, that means that in case F were to throw, we never reset the last executed, it's not going to count as a successful execution. What I might actually propose is, since we're already in this habit over here of wrapping, what we could potentially do is something like this. My initial intuition tells me that something like this might be a little bit nicer, which is catch throwable T. By the way, normally you would want to catch exception. I'm catching throwable because if you're using an assertion library, for example, I have one in Encore, which I use a lot. Normally those are throwables, not exceptions. So in general, I tend to catch it at a throwable level if I'm just talking about any kind of error at all. Anyway, if we have an issue on this, then, well, what do we want to do over here? Because the idea is we might want to return something like this, error T, but in that case, we want to make sure that this last executed happens on any branch. And what we could maybe do, just to make this code a little bit clearer, because this seems a bit weird that we produce the OK over here, but we produce the error over here, maybe we can do something like this, OK, over here, so that there's a little bit more of a symmetry. In other words, the entire result is calculated at this point, including the wrapper, so that we're not doing a little bit of the thing over here and a little bit of the thing over there. Does that make sense?
Previously, also, the result would have been OK result, and that would have been a map of error T.
Yes, exactly. That's correct. So that's a nice example of, I didn't even realize that. I was just being irritated by the asymmetry in the fact that we're doing a little bit of the wrapper up here and a little bit of the wrapper down there. I hadn't even registered that would be a problem in the error case because we would be double wrapping. So that's a case where sort of the aesthetic looked wrong to me, but actually there was a bigger problem than just the purely aesthetic one. It would have actually caused a problem on the return time. Now what I would do, and people are going to tell me I'm nuts for this.
Why? I don't know.
But what I would actually normally do in this particular case is do something a little bit ugly like this. I tend to use a very idiosyncratic style for how I align my code. I basically do things like this to, let's say, be able to consciously emphasize different parts of what I think is interesting or noteworthy in the particular code that we're looking at. And in this case, what I want to emphasize is there's two branches. There's the successful branch and the failure branch, and both of them are wrapper of something. This layout, even though it looks very weird, for me, at least my personal taste, would successfully emphasize that thing which I think is most important to emphasize at this point. You'll never see this in the wild. This is very peculiar. I do this kind of thing consistently in my code, but it's unusual, and most people would probably freak out if they saw something like that. Here, let's just check again that we've got our cases down. So this is all one particular branch. In order to remind myself of how many different branches we have, I actually use the code folding quite regularly for this kind of thing. So you'll see I've got rainbow parens in my Emacs over here. So when I'm on this let over here, it highlights the start and finish of the particular thing. But sometimes it's not super clear to read, or sometimes you might not have that. So what I'll do is actually just collapse the code so that I can see, again, I have an if, I have the test case, I have the first branch, so the truthy branch, and then the falsy branch. And it just lets me see at a glance, oh, yes, I still need to handle this false branch, and that might be separate to this false branch. All right, so what are we going to do in the falsy branch? We have previously executed something, but it's been too recent, so we're just going to return nil. So over here we have the previously executed branch. Then we've got the false branch. In other words, there is no previous execution. And you noted that now we're going to have some duplication, because no previous execution means basically that we want to return, okay, apply f args. But as you noted, there's actually this whole logic over here, because now we're going to have to do the catching and whatever on this other branch.
Yeah, so we're going to have to do this, basically, this whole thing again, just because we hadn't had a date set initially.
Yeah. Let's say in this case, we really don't want to duplicate all of this. So what I was advocating for a moment ago is let's just do it the nasty, ugly way with duplication, and then we'll come back and refactor. But in this case, we would be duplicating the majority of the interesting logic in our function. So let's just do it while we're here. What would be a way of avoiding this duplication? We could do something like this, system current time millis, so that it's initially equal to the current time when this wrapper is created, or we could do something like 0. In other words, it was executed at time 0. So the idea will be then we also take this opportunity to clean up a complication over here, which is we had this whole notion of making a distinction between nil and not nil last executed. We've noticed that there's an opportunity to remove that complexity. And instead of dealing with the nil, non-nil case, instead we just have last executed. It's always going to be non-nil. It may be 0, but that's all right. It's a number, and it works for our particular formula that we can get rid of this branching structure. In other words, we don't need to have a previously executed or not previously executed. Instead, we're just going to pull this right up into the same branch, which means that we can actually pull this right up over here. So we've got the now, we've got the last executed, which might be 0. By the way, another way of doing this would have been something like this, if we didn't want to put it in the atom itself. Doesn't make any difference here. But let's say that we've got the last executed over here. The elapsed is how much time has passed between now and the last executed. When the last executed is 0, that means that the elapsed time is effectively huge, right? So it's going to be, we presume, is always going to be larger than this msex period, which means that we can basically fall back to a single conditional over here. If the elapsed is bigger or equal to the period, then we're going to do this. I'm going to do a collapse over here. We're going to do this whole branch. Otherwise, we're going to return nil. And as we saw before, instead of doing a if x and then nil, we can just switch this to a let, which maybe reads a little bit nicer. So I've executed this function. We see that it evaluates, which means there's no obvious typos or something. Wrap once in a while, and let's say that it is a 100 millisecond window. Here, what are we expecting in the output so far?
So yeah, so it'll execute once and then return nil for the other two.
That's what we're hoping for, right? Let's run it. Ooh, and let's see. So this is cool. So here's an error that I wasn't expecting either. So let's debug it together. So class cast exception, Java long cannot be cast to clojure.lang.atom. So what does this imply? This error message may seem a little bit confusing on the surface. It's not written in a very descriptive style, but actually there's useful info here. Basically what it's stating is something that we're calling is trying to cast along to an atom. What does it mean to cast along to an atom? That means we're basically trying to treat a long as an atom. In other words, somewhere in our code, we're calling, for example, an atom API function on something that's actually a long. So what I would do is I'd go back to the code and check where are we interfacing using atom-like API. Probably we have done something strange with that. So last executed over here, we have an atom 0. Last executed over here, we have the deref of that thing. This looks all right to me so far. The elapsed is now minus last executed. And in particular, what I'm paying attention to is things like this is now the deref value, right? It's not the container, it's not the atom.
We're using in the reset, we're resetting the dereference value.
Exactly, good catch. This is, again, one of the reasons why I like to make the distinction between the container and the value. In this case, we can see we were trying to reset a long. In other words, we were trying to call an API function designed for the container on a long which doesn't support that API. So let's run this thing. There should be at least 100 milliseconds between executions. If our code is behaving the way that we would expect, we would hope to see only one println, and that is in fact what we're getting over here. So this looks good so far.
Okay guys, so I'm going to end this video here because the rate limit function is kind of working. There is one bug, and that's that this function isn't thread safe. And in next week's video, we'll look at how we can make this a thread safe function. So see you then. Cheers. Bye.